Hi, everyone. My name's Will Morse. I am the marketing specialist for InMotion US, a part of Zappy Group Companies. I'd like to welcome you to this session. Please remember that this session is also being recorded and will be available to watch on demand following our presentation. If you have any questions during the session, please add them to the Q&A. You can find that tab to the right of your screen. Note that questions will be sent privately. With that, I'd like to introduce our speaker, Daniel Vizzoli. He is with Zappi SPA, and he is an expert in cybersecurity with a master's in electronic engineering. Um, Welcome, Daniel. Go ahead and take it away.
Okay, thank you, William, for your introduction. Let me to share my screen. And let's start with the presentation. So, today we speak about cybersecurity, and in particular about the CRA and the cybersecurity requirement that this regulation introduced, along with the cybersecurity requirement required also by the machine regulation. And the second goal of this presentation is to define a possible workflow that can be used for the vehicle manufacturing to introduce the secure by design approach for the cybersecurity. So we'll start from a basic introduction to the Cyber Resilience Act, introducing the common concept. We'll continue with the machinery regulation cybersecurity requirement. Then we have an overview about two common standards related to the cybersecurity. They are the 62443 and the ISO 21434 that can be used to obtain the compliance to the CRA. And we conclude this presentation with a proposal of the design workflow that can be used for the vehicle manufacturing. So, if we start with the Cyber Resilience Act, this is a regulation released by the European Commission that is related to the cyber security of the product of digital elements that are manufactured, imported, or distributed in the European market. So the goal of this regulation basically is to introduce the secure by design approach into the product life cycle, and introduce also the vulnerability management. Third point is also to introduce also the concept of documentation in terms of cybersecurity, just to keep trace about the cybersecurity decision that the manufacturer decide, and also to increase the product awareness of the user that use the product. So the CRA introduced a different concept. The first one is the definition of product with a digital element. This product basically is composed of hardware and software components that communicate with other devices using direct or indirect connection and physical or remote interfaces. So it is a quite generic description that is intended to cover different sectors, and some of these sectors are covered, and some other are explicitly excluded. One example of a sector that is included into the CRA is the industrial sector. So all the electronic devices that are used, for example, for the material handling, construction equipment, and agriculture need to be considered into the CRA. An example of sector that is excluded from the Cyber Resilience Act is the automotive, and the reason is quite simple. This sector is already covered by other cybersecurity regulations, such as the R155 and R156, that already impose stronger constraints to the CRA. So there is no reason to include this product into the CRA. So just to understand why the product that belong to industrial sector need to be included in the CRA. The reason is quite simple. Typically, the devices that are using into the sector need to communicate with other ones, just for example, to move a specific vehicle, need to be configured, need to be updated for the software. So these communicate with others. So the vehicle, the ECU, and the software and devices that are intended to configure the ECU of the vehicle are all examples of product of digital element that need to be considered into the CRA. The second concept that is important for the CRA is the concept of pricing on market. In particular, the pricing of market is well described in another document released by the European regulation, that is the Blue Guide, that defines the pricing on market as the first moment when the single unit of a specific product family is made available on the European market. So from the pragmatic point of view, this is the moment when the single unit is shipped or supplied from the manufacturer to the end user. And this is an important concept because it doesn't consider the moment where the product family was designed, but only when the single unit is placed on market. So the concept of pricing on market divide the CRA timeline into different periods. The first period that started from December 2024 and will finish on December 2027 is called transition period. And into this period, the products that are placed on market don't need to be compliant to the CRA, excluded the notification of the exploited vulnerability. Instead, if the same product doesn't change, if it is placed on market after December 2027, these need to be CRA compliant. So the reason about the transition period is just to give to the manufacturer the time to make the component CRA compliant. There is a specific exception that are due to the spare part placed on market after December 2027 that are intended to replace the product placed on market during the transmission period. These spare parts are excluded. So for a manufacturer that already have spare part now that are placed on market, these can exclude immediately this category of product, simplifying the analysis of and the managing of the CRA. Another important concept of the CRA is the point of vulnerability management. The CRA asked to introduce the concept of coordinated vulnerability disclosure. That basically means keep the notification about the and final user that use your product, keep trace about it, and provide the security update just to fix this vulnerability. To allow the end user to notify the vulnerability, a point of contact need to be defined, so an address that the user can use. The vulnerability management need to be managed in the time frame called the support period that start from the moment when the product is placed on market. The vulnerability management in particular is very important because there is one deadline regarding the CRA that start from September 2026 when basically force the manufacturer to notify to the user and the authorities of European Commission to provide the information regarding the exploited vulnerabilities that are detected on the field. Instead, regarding the documentation, the CRA divided the documentation into categories. the first category of documentation is related to the information that need to be provided to the final user. And this category consider the software bill of material, the user instruction, and the declaration of conformity. The software bill of material is a list published in a specific format that indicate the list of software components that compose the software binary present in the product, and include also the external libraries that are used for the software binary. The external library in particular are so important because allow the user to verify what if there are some vulnerabilities into the software due to the external libraries. And it is also particularly useful for the manufacturer because it helps him with the vulnerability monitoring. Instead, for the user instruction, they are a set of documents that explain to the end user that need to install the product with the digital element, how to install it properly and maintain it in order to avoid the problem with the cybersecurity. The third document is the declaration of conformity, but that basically is a manufacturer declaration that indicates that the product is compliant with the CRA, and provide also, if they are used, some indication about the cybersecurity standard that are used to reach the compliance to the CRA. In the second category of documentation, there is the what are called technical documentation. So it is a set of documents that basically keep trace about all the cybersecurity relevant information related to the product. So they are information that don't need to be shared with the customer, but need to be available for the authorities in case there are basically some cybersecurity issue for the manufacturer. So this technical documentation contain different type of information. It contains, for example, generic description of the product, such as the internet purpose, and other particular detail, for example, architectural description, the risk assessment that is used to implement the cybersecurity, and that we'll see later during the presentation, decision about the vulnerability management project that we saw before, and the other the list of documents that is provided to the user. Most important concept introduced by the series is the secure by design, that is also the core of this presentation. So in particular, the series require to introduce the secured by design in the product lifecycle. Secure by design that start in particular from the design at finish during the commissioning of the product. This secure by design approach need to start from a risk assessment intended to detect what are the elements that need to be protected, and in particular, what are the damages in case these elements are not protected. And furthermore, the sharing requires also to place the product on the market using a secure by default setting, and to mitigate the risk of denial of service attempts that can stop the product functionality. Before to continue with the security by design requirement requested by the SRA, it is better also to note that also the machinery regulation introduce some cybersecurity requirement intended basically to protect the safety of the user. In particular, the requirements are intended to avoid that manipulation on software devices can affect the safety of the operator. And furthermore, in request also that basically a cybersecurity logbook is introduced on the machine just to keep evidence about the illegitimate intervention. An advantage of the machinery regulation compared to the CRA is that the machinery regulation has an harmonized norm dedicated for the cybersecurity that will be released into the final version into the next months. The disadvantage instead is that the deadline of the machinery regulation is on January 2027. That means 11 months before the Cyber Resilience Act. So if here we check the time frame of the machinery regulation, the Cyber Resilience Act, now we are more or less in the middle of the timeline. In particular, the next deadline that will come will be the obligation to report the exploited vulnerability on September 2026, and the deadline of the machinery regulation on January 2027. So just to summarize what we have told until now regarding the Cyber Resilience Act and the machinery regulation, there is Cyber Resilience Act required to introduce the security by design approach, starting from the risk assessment, without providing an harmonized norm that can help the manufacturer to implement the cybersecurity on their product. There are some horizontal standard at the moment, but they will be released into the next month. So at the moment, they cannot be used. On the other side, the machinery regulation has its own harmonized norm, but not all the devices that are present into the vehicle are safety relevant. So it is important to find a cybersecurity standard that can be used to obtain the CRA compliance and help also to obtain the compliance also to the machinery regulation requirement, because there is no overlap between these two regulations. And a possible proposal about the cybersecurity standard that can be used for the CRA, one of these is the 62443. The 62443 in particular is a cybersecurity standard designed for the operational technology sector. So we speak about the industrial sector, and in particular for the automation system. The goal about this standard is to define cybersecurity requirement that affect both the software policy and procedure that are used into the company, but also cybersecurity requirement for the particular product. And for the product, introduce also a classification about the capability of the product that are called the security level. The 62443 is divided in 4 parts, when the first part is the glossary. The second part defines the cybersecurity requirement that the asset owner need to satisfy. The asset owner is the organization or person that is responsible to define the cybersecurity requirement about the system. And if we consider the vehicle manufacturing, the system is the vehicle and the asset owner is the OEM. The part 3 instead defines the cybersecurity requirement for the system integrator, that is the person or organization that is responsible to take the cybersecurity requirement defined by the asset owner and implement the system, defining also the cybersecurity requirement for the ECU that compose the system. And in the case of the vehicle manufacturer, the system integrator in some cases can be the asset owner. The last part instead defines the cybersecurity requirement for the component manufacturer. This cybersecurity standard has some pros and cons. The pros is that currently is recognized as the closest standard to be used for the CIA compliance. It was proposed by some document released by the European Commission, but was also detected from some company that works into the industrial sector. It provided the classification about the security capability level and introduced one of the most important concepts for the cybersecurity, that is the defense in depth. In particular, for the defense in depth concept states that in a system, it is impossible that an SU is responsible for the cybersecurity of the whole system. Typically, the protection of a specific asset need to be splitted in between the SU that compose the system, and both hardware and software mechanism shall be used to protect this asset. The 62443, from the pragmatic point of view, has some cons. In particular, it is designed for the automation system, so it is that involve PLC, SCADA, but also internet connection. So all elements where typically there are no problem about resources and technology. The situation is different for the embedded system. So typically the 62443, if a manufacturer want to use it, and this is not mandatory, need to take the cybersecurity requirement defined by the 62443, check one by one, and try to adapt them for the embedded product that it needed to develop. And the second disadvantage is that for some cybersecurity requirement, it is impossible to reach the maximum security level, because in some cases it requires specific technologies to be implemented. To make an example, in some cases requires to use the two-factor authentication that from some embedded system are not applicable. Most important problem is that the 62443 require to use the risk assessment to start the cybersecurity analysis without providing a method or an indication to implement it. So for this purpose, another standard can be used, and this standard is the ISO 21434. The ISO 21434 is the cybersecurity standard that can be used to reach the compliance to the automotive cybersecurity regulation. So it is a standard that has some similarities with the 62443, but also some differences. In particular, this standard defined also in this case some cybersecurity requirement for the internal processing. Obviously, it imposes stronger constraints compared to the 62443, because the risk associated to the automotive sector are typically considered more important compared to the industrial sector. But the big difference is that this standard is more focused on the risk assessment. And in particular, this standard introduced the concept of TAR, that is the procedure of the risk assessment, and it provides dedicated chapters, section, annex to guide the manufacturer to implement the risk assessment. So it is a good point to start for a person that need to start from the beginning for the cyber resilience with the Cyber Resilience Act compliance, but it has some cons, and in particular, it lack of all the element introduced by the 62443 regarding the cybersecurity requirement of the product and the classification about the security level. So one proposed workflow can be start from a simplified version of the TARA approach proposed by the ISO 2144, detect what are the assets that need to be protected, define the cybersecurity requirement that need to be defined for the specific product, and after this, pass to the 62443 just to have some indication about the possible cybersecurity functionality that can be implemented on the product, and also to have the classification for the capability of the product. So just to move this consideration to the vehicle. The vehicle can be considered as a networking system. As I told before, this vehicle should have some asset that will need to be protected. These assets are typically spread between the ECU and need to be protected. Need to be protected following the defense in depth philosophy. So introducing different layer of protection for the different assets. And to start to introduce the cybersecurity into the vehicle, a possible workflow can be used. That is this one. There are both the tasks that need to be considered from the OM point of view and the ECU supplier point of view. In this particular case, I consider the easier case when the asset owner and the system integrator are the same person. And into this case, the OM need to start from the risk assessment on the vehicle. From this risk assessment, it needed to define the cybersecurity requirement that come from the risk assessment, and from this risk assessment, it need to provide to the supplier the cybersecurity requirement for the specific ECU. The ECU supply on its side need to start in parallel of the OM conducting a preliminary risk assessment on the product intended to detect what are the assets and therefore the damages that are independent from the application, and from this asset and risk assessment evaluate extract the cybersecurity requirement. An example about asset that can be protected independently by the application can be the firmware, the diagnostic data, and so on. After this, the cybersecurity requirements are obtained. This has to be integrated with the cybersecurity requirement defined by the OM that are specific for the particular application. After this, when the complete list of cybersecurity requirements has been defined, the ECU supplier can propose a possible implementation about the solution to the system integrator, and after an agreeing phase, it can start with the implementation phase and then the test. For the people that already work with the safety, they can find immediately some similarities because typically both cybersecurity and safety can be managed in the same way, adopting some strategy, for example, DV model and so on. Before to conclude the presentation, I want to provide you some suggestion to start the risk assessment in case it is the first time that you have to start with this activity. And the first important point for me is to start from the interface identification. The interface identification is very important because it allows the manufacturer to detect immediately what are the access point of the network, distinguish them between physical access point and remote access point. Remote access point typically are considered more important because typically allow the attacker to attack more product, in this case more vehicle at the same time without being on the field. And when the access point are defined, it is better to classify what are the what is the intended use of these interfaces. Then understanding if they are used, for example, for communication, for the software update, configuration of the product or component, and so on. And after that, the interfaces are defined. Try to understand what are the mechanism, physical and software, that can be used to protect these interfaces, and also evaluate what happens if these protection mechanisms are bypassed from the attacker. Once the interfaces are defined, the next step is to identify the asset that, in case of the vehicle, are typically associated to some data that are transmitted or stored into the CPU and that need to be protected. In particular, a complete list of the assets need to be created, and for each asset, identify what are the cybersecurity properties that can be compromised by an attack. And typically, the cybersecurity properties are the confidentiality, the integrity, the authenticity, and the availability. Once the interface and asset are identified, the last step is to proceed with the risk assessment. In particular, evaluate what is the negative impact in case an asset is compromised, but also the feasibility of the attack, because an asset can have a very dangerous impact in case it is violated, by the feasibility of the attack can be low. So into this case, the risk has to be evaluated considering both the elements. After the risks are identified, the next step is to evaluate how to manage them, and there are typically three choices. The choice is to mitigate the risk from the component or from the system, or to share the risk, and this is particularly done with the component. The component can choose to share the risk with the operational environment in case it has not direct access to the particular asset, or it cannot provide, for some limitation, protection to the mechanism. And share risk basically means to introduce the concept of defense in-depth approach that we have seen before. And the third risk is to keep the risk, but this strategy typically can be followed in case the risk is very, very low, and in any case, it needs to be documented into the technical documentation about the product. The last suggestion about the risk assessment is to avoid to over-engineer your product. In particular, if you want to use the 62443, this means to define well what is the security capability level of the 62443 that you want to use. The 62443 in particular has a 4 level. Typically, the last level means to protect your product from attack of other countries. So for the industrial sector, typically this security level is not required. So if you have not started yet with the cybersecurity analysis, start with this as soon as possible, because you have seen that the machinery regulation deadline, but also the SRA will come soon. And I also thank you about you are here. Thank you.
Awesome presentation, Daniel. We looks like we have a couple questions here in the chat. First one, let's see how to word this. What do you think can be a possible effects of the cybersecurity leak in relation to industrial trucks, and what is the possible countermeasures? I assume what they're asking here is, can you give us maybe an example of why somebody or would want to leak the information from a piece of machinery, and what is maybe one example of helping prevent that?
Sorry, can you repeat the question, please?
Yeah. What do you think can be possible effects of cybersecurity leak in relation to industrial trucks? I assume this could be for like mini excavators, trucks, anything EV. What's the possible countermeasures? So I would just give an example of one countermeasure, like for a
Countermeasure
system.
for countermeasure for the cyber for the vehicle depend basically about what are the associated risks. For example, if we your truck basically has use, for example, the telemetry, this introduce the access remote, but also if your vehicle has easy access from the physical point of view, this can be dangerous. So one of the possible solutions is to use, for example, a gateway in the middle of your network. So into this case, this is useful basically to split the network into different segments, prevent that messages that are not intended to go into the network can be used. This is not the unique way to protect, because in any case, the gateway cannot protect the vehicle by the messages that need to go through the internal network of the vehicle. So you can obtain, for example, a denial of service attack using some of these messages that are present in the network, using, for example, the ID priority that are present on the CAN. Other mechanisms that can be used to protect the vehicle is to make the access to the internal network more difficult, or act, for example, at the directly to the ACU level. And this approach can be useful because some cybersecurity attack can consider to protect the CU also when it is not on the track. So consider, for example, the case when you have to update your ECU before it is mounted on the track. So into this case, for example, you have to ensure, for example, a secure update mechanism if it is a particular requirement from the supplier. So it is not always mandatory, but this can be a possible way to protect. So the mechanisms that can be used are strictly related to the network structure and the access point of the vehicle. So not all the vehicles are the same, and it is honestly impossible to mitigate all the risks. So also in this case, a residual risk need to be accepted according also to the vehicle
So,
usage, basically.
so we had another question here asking kind of about AI. What are your thoughts on that in cybersecurity in the future?
The AI can be used in different elements because it can help the manufacturing into different way. For sure, it can be used during the risk assessment because it can help the manufacturer to detect what are the cybersecurity standards that can be used, what are the best practice. Try
I
to
guess
every try to have
um, I guess more of the question is the risks of AI trying to attack.
sorry.
Yeah, no,
The
you're
risk
fine.
of the risk of AI. In this case, the risk AI is a bigger question because it can help an attacker that have not cybersecurity correct knowledge to make attack easier. So there is a trade. The problem is on both sides. So it can help the manufacturer, but it can also help the attacker.
It's kind of a black box right now.
Exactly.
Um, Another question here. If we already follow cybersecurity requirements of the machinery regulation, does that mean we are automatically covered for CRA?
Absolutely not, because
Okay.
there is no overlap between machinery regulation and cyber. Mm, there is not a total overlap, let me say, between the two. In particular, the CRA impose more requirement compared to the machinery regulation. So, what the best way to proceed is that consider both CRA and machinery regulation and try to obtain with the same analysis the compliance with both the regulation.
All right. Um, let's see what else we have here. If a cybersecurity vulnerability doesn't create a safety risk, do we still need to report it to the ECU manufacturer? So if there's
Yeah,
no physical risk.
yeah. The CRA make no differences between vulnerabilities and safety vulnerabilities. So if you are an end user, you have to notify to the manufacturer all the vulnerabilities that are detected on your target. I speak about cybersecurity vulnerability for sure because the vulnerability can be managed into a different way, and in particular for the cybersecurity vulnerability, the point of contact that will be provided by the manufacturer before September 2026 need to be used.
Gotcha. All right, let's see. Got two more here. Da-da-da-da. What if a vulnerability is identified, but it cannot be technically fixed on the product? So there's no way to fix it without replacing the product or the component.
This is a big problem. So there are different ways to proceed into this sense, in the sense that in any case, the situation need to be documented and need to be in some way mitigated. The way that can be used to mitigate this is, for example, to act from the operational environment where the particular issue that is not to able to match the vulnerability. And in particular, the operational environment need to introduce some compensating mechanism just to help basically the issue that is not able to fix. this. And the second approach, when it is feasible, replace this SU with a new version that is able to fix the problem. I can see this scenario probably at the end of product life cycle after this product family has been released on the market from several years. So we reach a point where the technology that was used when the product family was developed was so old now compared to the cybersecurity technology that is used. So it is very, very difficult. Instead, if this happens for a new product, probably this means that the product was not designed into the proper way. But in any case, this is not. It is a problem for the system integrator and the component manufacturer, but it is not a problem for the authority in the sense that typically the authority check if you have to have designed your system and component into the proper way. After this, the best way to proceed is that the system integrator and the manufacturer has a good strategy that is need to be documented into the vulnerability management just to avoid this type of situation, or in any case where they indicate how to manage this.
Awesome. All right. Let's see. Do we need any third-party certifications to issue the declaration of conformity, or can it be done by the manufacturer?
Okay, this is a good question, and I a little bit long, so I try to simplify. So basically, the Cyber Resilience Act provide you some category to classify your product, and these category are called default, important, and critical product. And to recognize if the product is entering in one of these category, some annex of the Cyber Resilience Act provide you some indication, and additional documentation that has been released on December 2026 provide you complete description about the product that enter into this category. So according to the category, you can proceed with an auto certification or a third-party certification. In particular, if your product category is considered as default, for this category, you can use the auto certification. For the product that are called important, there are two classes of important product that are called class 1 important product and class 2 important product. And in particular, for the class 1, if you have an harmonized norm for the CRA, and you are currently, we have not yet it, we can use the auto certification. Instead, if the harmonized norm is not present, you cannot have the you have to use the third party notification. For the class 2 important product and critical product, instead you have to use third party certification. So in any case, the CRA provide good description about the best way to proceed regarding this point.
So maybe time for one more question, and we'll wrap up. Let's see. So, how do we handle risk assessment for an ECU that during its lifetime might end up operating in different contexts? So, I guess different applications.
Or different application or different phase of the product.
Life cycle.
I can to answer to both. In case the same product need to be used in different application, a different risk assessment need to be considered for each application because the operational environment for this application can change. So in any case, what could happen is that also the firmware that is present into the product is different. So this is an additional reason to make a different risk assessment. In case we speak about different operational context of the same product during this life cycle, basically all these contexts need to be considered into this array. The example is the one that I showed before during my presentation. If we consider, for example, a vehicle ECU, I can, for example, I have to manage the case when it is not yet mounted on the vehicle. So there is some risk associated to the fact that I have a direct access to the vehicle that I have not when it is mounted on the vehicle. And instead, when the vehicle is mounted on the vehicle, I have to consider that it has communicated with different devices that can be potential point of attack for my particular ECU.
Well, I think that wraps up everything. Do we have anything else? Okay. Oh. All right. Thank you for your talk, Daniel. I hope you
Thank you
enjoy your
too.
day. And thank you to everybody that attended the session. This will be able for recording. So we will post this later. Let us know if you need anything else. Have a good day.
Have a good day. Bye.